Good morning friends, I welcome you all in this session. As you are aware, in previous session we were discussing about time and cost relationship, and we have seen that as far as direct cost is concerned, whenever we crash a project, its direct cost increases, while indirect cost is directly proportional to the duration of the project. When you decrease duration, indirect cost will decrease. When you increase duration, indirect cost will increase. So at the end of the day, we want a total cost which is minimal, right? And we have seen a method of crashing of a project, wherein what we did, first of all we calculated the total duration of the project, then we found critical path. After finding critical path, we reduced those critical activities for which the slope was lowest, isn't it? And every time we reduced duration of critical activity by 1 day. Why 1 day? Because whenever you reduce duration of critical activity by 1 day, there is a possibility of creating another critical path. So if we had reduced a critical activity by 2 days, we would have missed a path which might have generated if we had reduced it by 1 day, right? So that is the reason we every time reduced duration of activity by 1 day. So that was quite a simple method, however lengthy method, but quite a simple one, right? And it gives you optimum solution. Now let us talk a different method which is quite an efficient method. However, since it is efficient, it is difficult, right? So we will discuss a method called free float method, crashing of a project by free float method. Let us look at this question. Here you have got different activities. So these are different activities, right? Activity 1, 2, normal time is 5 days, normal cost 200, crash time 2 days, crash cost 260. It means you can reduce the duration of activity 1, 2 up to 2 days, right? Right, it is not by 2 days, right? It is up to 2 days. So crash limit or the delta t is 3, this is also known as crash limit, and change in cost is 60, right? So for 5 days cost is 260, for 2 days cost is 260, right? So change in cost per day is 20 rupees. So this is for activity 1, 2. Similarly for activity 5, 6, you have been given normal time, normal cost, crash time, crash cost, and this is delta c by delta t. In other words, this is slope, right? So the total cost of this project is 1980, right? This is total direct cost. We have been given indirect cost also in this question. So let us start solving this question, but before we start solving this question, let us revise some of the concepts of floats, right? What is float? Float is nothing but you can delay a particular activity without affecting duration of the project, right? That is float. And we have seen 4 types of floats. We have seen total float, we have seen free float, we have seen independent float, and safety float, right? So this is what we have seen, and all of you know what is earliest start time, earliest finish time, latest finish time, latest start time. This is total float, right? So TLJ minus TEI minus duration, TEJ minus TEI minus duration, independent float TEJ minus TLI, right? So if you look at the formula for total float and independent float, these two terms are now interchanged in this particular formula for independent float, right? And finally this is what we have seen in previous session also. So if you want to calculate free float, this is TEJ minus TEI, right? So both are earliest, this is finish time, earliest start time, right? And this is what also we have seen in previous session. So let's come back to this question. This is a question in which you have been given indirect cost as 40 rupees per day. So we have to find optimum solution by free float method, right? So let us start solving this question, and initially you have got a network like this, right? So from this table we have prepared this project network, right? So let's solve this question, and this is quite a lengthy and complex method, but since you can since you have got computers, you can write a program and you can efficiently solve questions like this, right? So the first network is this. So this 1 2, this is 3, this is 4, 5 and 6, right? So sixth node is the last node. No, there is no connection between 3 and 4, it is between 3 and 5, right? So there is no dummy activity. So let us write down their time durations. This is 5, this is 6, this is 7, this is 4, this is 5, this is 4, this is 7, right? And for 4 6, this is 6. So you just check your durations. For activity 1 2, for activity 1 2 it is 5, for 1 3 it is 6, for 2 4 it is 4, 2 6, this 7, 3 5 5, 4 5 4, 4 6 6, and 5 6 7, right? So let's get started. So first of all, let us find out critical path, right? So TE is equal to 0, TE is equal to 5, TE is equal to 6, TE here is 9, right? 5 plus 4 9. Then T here would be 9 plus 4 13, 6 plus 5 11. So this is 13. Here it would be 20, right? 13 plus 7 is 30, right? Let us look at TL values. TL is equal to 20, TL is equal to 13, right? TL here is 13 minus 5 is 8, right? 13 minus 4, TL is 9, right? Of course TL from here it would be 20, right? So let us not write that value. So TL here is 5 and TL here is 0, right? So which path is critical path? This path is critical path. Right. So critical path is 1 2 4 5 6, right? Now we have also seen in previous session that the critical path is a path where you have a total float, free float and independent float, all are 0. So there is, so along this path total float as well as free float are 0, right? Now in free float method, the first thing you should do after finding critical path is you should find free float of non-critical activities, right? So non-critical activities are 1 3, 3 5, 2 6 and 4 6, right? There are 4 non-critical activities. So let us find out their total free float, right? And free float is what? It's, we have seen what is free float. It is earliest time, right? So this is, just see this, TEJ minus TEI, right? So TE minus TE, not for critical activity, right? Let us calculate it for non-critical activity. So 13 minus 6 is 7, 7 minus 5 is 2, right? Critical path for activity 4, 6 would be 20 minus 9, 11 minus 6, it is 5, right? So free float is 5. Free float for activity 3, 6 would be, it's 20 minus 15, 20 minus 5, that is 15, 15 minus 7, that is 8. Free float for this 6 minus 0 minus 6, so free float is 0 here. So if you look at in this question, we have calculated all the free floats of non-critical activities, right? Now let us start crashing this network, right? So first of all, we should write what? We should write what is critical path. So critical path is 1, 2, 4, 5 and 6, right? What is the slope? Slope for activity 1, 2. What is slope? Yeah. Here these are nothing but slopes, right? So this is 20. So for activity 1, 2 it is 20, right? For activity 1, 2 it is 20. For 2, 4, for 2, 4 it is 40, right? For 2, 4, this is your activity 2, 4 and this slope is 40, right? So this is 40. For 4, 5 it is 40. 2, 4 and 4, 5. So 2, 4, 40 and 4, 5, 40. Then we have what? 5, 6 which is 30. So for 5, 6 is 30. Then you have to see their crash limit, right? Crash limit. Crash limit for 1, 2 is what? It's delta t, right? So for 1, 2 it is 3, right? So 3. For 2, 4, simply you can you just subtract normal duration. From normal duration you subtract crash duration, right? So for activity 2, 4 it is 2. For 4, 5, 3, 4, 5 also 2. So 2, 4, 2, and for 5, 6 crash limit is 3, right? So this is the first thing you should do, right? Now which activity should be selected for compression? For compression you should select activity 1, 2 which has got least slope and its crash limit is 3, right? So when I say crash limit is 3, you can reduce this duration from 5 to 2, right? In previous method we reduced its duration from 5 to 4 first, then 5 to 3 and so on, right? In free float method we will not reduce this activity by 1 day. We will try to reduce it by more than 1 day. And how to decide that duration? Should we reduce, should we compress it by 2 days or 3 days, right? So since this crash limit is more than 1, we will apply something called test step. There is something called test step. Test step. So in test step what we will do, we will reduce the duration of activity 1 2 by 1 day and see the effect of that change on free float of non-critical activities of this network. What is test step? We will reduce the duration of activity 1 2 by 1 day and we will see how these free floats are changing of non-critical activities, right. So this 1 2 3 4 5 and 6, right. So let us reduce its duration by 1 day, right. Since this is test step, so we are reducing it by 1 day and we will keep all other durations as it is, right. This is 7, this is 4, this is 5, this is 4, 6 and 7. Right. Let's see what happens on free float of non-critical activities. So TE here is 0, TE here is 4, TE here is 6, TE here is TE at this point is 4 plus 4 8, right. 8 plus 4 12, okay. So this is T is 12 here, 12 plus 7 19, right. Let us find out TL values. 19, 12, this is TL is now 12 minus 5, this is 7, right. So this is 7, TL at this point would be 8, right. This is 12 minus 4 is 8, TL at this point would be, and 8 minus 4 is 4, TL at this point is 0, right. Free float, it was 8, 13 minus 5, it was 8 here, so this is 12 minus 5, 7, okay. So we have calculated all T's and TL's. Let us find out change in float of non-critical activities. So which were the non-critical activities? This was the non-critical activity, right. So TL, so free float for this would be T minus T, right. So 19 minus 4 15, this is 8. Free float of this would be TE minus TE 6, so free float is 1, and the third non-critical activity was this, right. So TE minus T, so free float of this non-critical activity is 0, and there is one more non-critical activity which is this, right. So free float here is 19 minus 8, 11, 11 minus 6, that is 5. So what has happened to the free float of non-critical activities? If you check carefully, this was 8 in this network and this is also 8. So there is no change in this free float. Free float was 5 here, free float is 5 here also, free float 0 here, free float is 0 here, but free float which was 2 here now reduced to 1. So this is the change in free float. So what is the meaning of this? When we reduced the duration of activity 1 2 by 1 day, what happened? The free float of 3 5 reduced from 2 to 1. Had we reduced this duration from 5 to 3, this would have become 0 and this would have become a critical activity. So free float method will help you in knowing which non-critical activity might become critical activity in future, right? So this is known as free float limit. So free float limit of activity 1 2 is 2, right? Free float limit of activity 1 2 is 2. We don't have to see this limit, right? We will have to check this limit, right? So free float limit of activity 1 2 is 2. Its crash limit is what? Crash limit is 3. So compression limit would be minimum of these two, which is 2. It means you can reduce the duration of activity 1 2 by 2 days, right? So let us reduce its duration by 2 days. Had we applied previous method, we had reduced it by one method, but since we are applying free float method, we have checked that if we reduced this duration from 5 to 3, then also of course a new critical path would generate, but it would not be bypassed, right? What is the meaning of bypass? When I say bypass, means when you have got more than one critical paths, you need to reduce critical activities along both the paths, right, to reduce duration of the project. So we have decided that we will compress activity 1 2 by 2 days, right? So let us take that decision and compress its duration, right? One, 2, 3, 4, 5, 6, right? So let us make it 2, right? All other activities will remain same, right? So this is 7, 4, 4, 7, 6, 6 and 5. Let us find out, is there any new critical path generating? So TE at this point is 0, TE at this point is 2, right? TE at this point is 6, TE here is what? It is 6, right? 2 plus 4 is 6, right? So 6 plus 4, 10, this is 11, 11 plus 7, 18, right? Of course, since we reduced this activity from 5 to actually compression limit is 2, so we will reduce it by 2 days, so this would be 3, right? So when this is 3, this is 3, this is 7, right? This is 7 plus 4, 11, and this is also 11, and this is 18, right? So when we take this value as 3, this is our TE at the last node, right? So TL 11, TL here is 11 is 7, and TL here is 11 minus 5, this is 6, isn't it? This now this has become critical, right? This is what we tested over here, right? TL is equal to 0 and TL here is 3, right? TL at this node is 3, right? So which are now critical activities? The critical activities are 1 to 2, 2 to 4, 4 to 5 and 5 to 6. So this first critical path, and we are getting one more critical path, which is this. So now we have got 2 critical paths, right? So since we have got 2 critical paths, what we should do, critical path, you got 1, 2, 4, 5 and 6, right? And 1, 3, 5 and 6, right? Right there slopes, right? So we know slopes already, so 20, then 40, then 40, 30, right? For 1, 3 we need to find out slope, right? So for activity 1 through 1 3, slope is 30, 3 5 is 20, right? So 30 and 20, 30 and 20. For 5 6, what is the slope? 30, right? So 30 20 30 20 40 40, right? Now since we want to reduce duration of this project, what we should do, we should in fact you will have to reduce both the critical paths simultaneously, or activities along both the critical paths simultaneously, right? So the minimum slope is, okay, the minimum slope is this, and let me write crest limit also. This is now 1, right? Earlier it was 3, right? So you can reduce activity 1 2 by 1 day only, right? So similarly you can write crest limits for others also. This is 2, this is 2, this is 3, this is 3, this is 2 and 3. Now since you have to select any of these activities and any of these activities from these 2 critical paths, crest limit is 1. So from here you should select this activity, and from here you should select this activity, right? Your direct cost will increase by 40 rupees, isn't it? So should we go for test step here? Since crest limit here is 1, there is no need of test step. When we go for test step, when the activity which you have selected for comparison, its crest limit is more than 1, then only you go for test step. So here in this case, now there is no need of going for test step. You just crash it by 1 day, right? So let me stop here for the time being. In next session we will continue with this example. Thank you very much.